All right, let's kick this off. I've had the opportunity to work with Michael on a few projects in my time here at Fivetran. He's dynamic, amazingly technical, and amazingly personable as well. So I'm super excited to welcome Michael Kaminsky, who is an entrepreneur. He's also one of the co-founders of an amazing data community called Locally Optimistic. So if you haven't checked out that Slack community and you're a curious data practitioner, you should. And without any further ado, Michael, take the stage, please.
All right, great. Here we are. Thanks for having me. It's great to, I can't actually see all of y'all here, but if I were seeing all of y'all, I'm sure y'all would look very handsome and beautiful all across the field. Thanks to y'all for coming. I'm really excited to talk about this. Big thanks to Fivetran for organizing and putting on this digital conference. As Jason mentioned, I'm gonna leave a couple minutes at the end for questions and discussion, but this is a pretty short talk, so I'm gonna jump right in. So really quickly, here's my contact info and where you can find the materials for this presentation, plus the speaker notes if you want to read along or for whatever reason the audio doesn't work for me. You can hit me up on Twitter at Mike_Kaminsky if you have any questions, or anytime if you really just want to chat data. So a little bit of background about myself. I'm a data scientist by training, although I've also dabbled a fair amount in software and data engineering. Back in the day, I built and ran the data team at Harry's, where I spent a lot of time thinking about how to run a modern data team efficiently. And these days, in addition to working as an entrepreneur in the data space, I spend a lot of time helping to grow the Locally Optimistic community, which you should join if you aren't over there already, and advising companies on their data strategy. One of the reasons that we're all here today is that interest in data and data-driven applications has seen incredible growth over the last 5 or 10 years. All of us probably recognize that there's been a little bit too much hype in the space. But to some extent, we've also all probably benefited from that hype. As a lot of money and interest has been flowing into data teams and into our paychecks, we've seen more demand for the type of work that we do. That's really exciting. Unfortunately, the results have not been as good as some people had hoped for. The data science and AI revolution has, for many organizations, failed to deliver on the value that was promised. This famous study out of MIT Sloan from a couple of years ago showed that 7 out of 10 executives whose companies had invested in AI have not seen any value from their efforts. And if you're like me, this probably resonates with you. We've all heard the stories about data scientists frustrated that they're not able to deliver value. Executives who are disappointed when ML projects they dreamed up don't magically generate heaps of cash. This might surprise some of you, given that I am a data scientist, but I've spent the last 5 years begging companies not to hire data scientists. I promise you this isn't some type of masochism, and I apologize to all of you who are applying for these jobs that I was advocating for canceling. Here's the thing. I really do believe that data scientists can generate a lot of value, but I'm also very aware that for many organizations in the last few years, hiring a data scientist would just have been immediately setting that person up for failure. I've talked to a gaggle of executives who wanted to hire data scientists simply because they'd heard the data was important and everyone else was doing it. Maybe their VC told them that they needed a data team. They'd all read the same article in the Harvard Business Review and they didn't want to be left behind. We've all heard this story 1,000 times of data scientists showing up at their brand new job, ready to import scikit-learn and really just science the hell out of some data, only to find out that there is no data, or it's in a terrible format, or it's not accessible, or there's no tools to work with, or. These data scientists are not at all set up for success. Data scientists need good, clean data to work with in order to add value, or else they end up just doing a lot of software and data engineering, but badly. If you hire a PhD in physics and they end up working on building out basic reports in a BI tool, everyone is going to be having a bad time. So this isn't a novel idea. Many people much smarter than I am have talked about the data hierarchy of needs, the data pyramid of priorities. This pyramid is, of course, analogous to Maslow's hierarchy of needs, which is a psychological theory that describes how human beings can achieve higher and higher levels of psychological fulfillment, but only once more basic needs are met first. The data hierarchy of needs functions the same way. Only once we've met the needs at the base of the pyramid can we move along to the top. If we don't have data collection, we need to start with that. Then once we have our data collected and stored, we can move up to the next level. Data cleaning and access, where we can make sure that data are meaningful and match real world business concepts that our business cares about. And that people can access those data either via a data warehouse or a data lake. Next on the list, we have descriptive analytics and BI. Can we provide basic metrics to the business based on the data that we have? And can we do that efficiently in a way that ideally doesn't flood our data team with lots of one-off requests? So if a company is still working at the bottom of the pyramid and they hire a data scientist, everyone is going to end up frustrated. The executives are going to be frustrated because they've hired a very expensive data scientist and yet no data are being scienced. The data scientist is going to be upset because they want nothing more than to just science those sweet, sweet data, but yet they end up trying to write a log parser that can run on their laptop in order to be able to start working at all. So this is a bad match for both sides, although it's a great way to generate a lot of Medium articles where those two groups of personas talk past each other. Only once we have all of those pieces in place can we move on to data science and AI. So for the last 5 years, my advice has always been, don't think about AI until you've got your data cleaning and BI systems working well. We need to be focused on the bottom of the pyramid, on meeting our most basic data needs first, before we even start talking about hiring data scientists. The vast majority of companies 5 years ago, and I wager that even most companies today, excluding probably a lot of people who are represented here who are ahead of the curve, did not have those basic needs met. And so hiring data scientists was a losing proposition. So what happens when you ignore this advice and hire data scientists without having your basic needs covered first? We've all heard about this apocryphal, but at least a grain of truth statistic that data scientists only spend 20% of their time actually working on data science. But instead, they actually spend the majority of their time doing other non-science tasks like data cleaning or munging or extracting, or even just doing basic reporting tasks that the business is demanding. These are all tropes within our field, and it's the recurrent issue that has launched 1,000 Medium posts. But of course, this is all related. Executives don't feel like they're getting good ROI. Data scientists are frustrated that the job they applied for doesn't match the work that they're actually doing. And it all stems from the issue that organizations hired data scientists before they had their other data needs met first. Our companies are investing lots of money in these data science teams, but because of a lack of good tooling and data availability, data scientists aren't able to work productively. And so the company does not see the type of ROI that it's looking for. One thing to quickly note before we move on, this advice and the content of this talk in general is not directed toward or about the big tech companies that have been working at the cutting edge of data science for a while. Those organizations have been hiring and making great use of data scientists and investing in building lots of high-tech tools, and they'll likely continue to do so. This talk is more addressed to the rest of us, to those companies that have more limited technology budgets or where they are tech-enabled businesses rather than tech-first businesses. You'll see in a few minutes that what I'm talking about here indicates that we as these sort of follow-on companies can actually get a lot of the features of the very expensive platforms that your Ubers and your Googles have been building, but in a way that's actually obtainable for us. So everything that I've talked about so far has sort of been in the past tense, right? What's been happening over the last 5 years? And this raises the question, have times changed? I've been preaching the don't hire data scientists gospel over the last 5 years, but I'm excited to say that now I think that we, the data industry as a whole, might actually be ready to graduate to the next level and move up to the next triangle on that data hierarchy of needs. With the modern data stack that's been developed over the last few years, I believe that we're now at a place where normal companies can support data scientists in a way that will make them many times more productive than they could have been in the past. Everyone at this conference is probably already familiar with a diagram like this, but for posterity, I'll quickly cover it. The modern data stack is made up of 3 main components: an extract and load layer, something like Fivetran, takes care of getting data out of upstream sources and into a data warehouse or data lake. Then within the cloud data warehouse, we have a transformation management tool, something like dbt. There's a few other companies that also work in this space. And then at the bottom, we have BI tools that allow the business to get insights from the data. This is now becoming very standard. What's so amazing about the modern data stack is that at this point, it's mature enough to be reasonably plug and play. We're having a whole conference about it even. Back when I was getting started doing this work 5-6 years ago, most of these tools that we take for granted today didn't even exist. At Harry's, we built our own internal version of dbt. We built our own ingestion pipelines. We had a slew of data engineers. Looker didn't even have the ability to make dashboards back then. But now the whole stack has matured to a point where it's straightforward to set up a stack with tooling that will work really well in a matter of weeks. One quick note, I'm going to use the term data warehouse and data lake interchangeably. My belief is that with cloud data warehouses like BigQuery and Snowflake, the line between lake and warehouse has grown sufficiently blurry that it's not really worth differentiating in most use cases. So with the modern data stack, we can check off a lot of these boxes in our data hierarchy of needs. We've got data storage and access via cloud data warehouses like Snowflake and BigQuery. We've got cleaning and processing via tools like dbt. And we've got lots of great BI options to choose from with tools like Looker, Mode, and Tableau. For the remainder of this talk, I'm going to talk about what it looks like to build a data science practice on top of the modern data stack. I believe that although it adds some additional overhead to the traditional data science workflow, if we architect our data products to take advantage of the modern data stack, we can get our data scientists building and shipping more models while doing less data cleaning or struggling with deploying. Getting started can be tough. So today I want to talk about what those next steps look like for organizations that have their data stack set up and are looking to break into data science in a way that's efficient and leverages the investment that they've already made in their data infrastructure. Before we get into the weeds, let's talk about what we actually want from our data scientists. How do we want them to spend their time? One belief I have is that data science teams, especially at these smaller companies, create the most value when they ship lots of new products. And so I want to build infrastructure that supports having a data science team ship as many data products as possible. In order for the data scientists to ship lots of different products, we need the data science team to have an environment where it's very easy for them to train and deploy models. So the easier we can make it for the data scientists to access the data, train a model, and then deploy the model, the more products they can build, the more products they can ship, and the more value we can get out of our data as a business. So we want our data scientists to spend very little time on data extraction and cleaning, and also very little time on productionalization and how to deploy to AWS or whatever the case there is. But rather what I want them doing is writing a simple query and then spending all of their time on training and tuning their machine learning model. That's where the data scientist is adding the most value. And so that's where I want them spending their time. So for those of you who aren't familiar, let's talk a little bit about what the traditional data science workflow looks like. Back in the old days, this is roughly what the job would be. When I was starting a new project as a data scientist, the first thing I was going to do was go on a hunt for the data. That might mean bargaining with a salty sysadmin type in order to get query access to a database. It might mean calling a data provider and then waiting for them to FedEx me a hard drive with data on it. Yes, I've actually done that. Or it might mean trying to cobble together a data set from a myriad different data sources and wild formats. Many people here have probably encountered these types of odd data formats in Excel or PDF or even some exotic text files. All of this is a huge pain and can be an enormous time suck for a data scientist, all before even starting to do any science work at all. Next up is then trying to understand the data once I have it. You might have two columns that seem like they should reflect the same concept, but they don't always match which column to use. Two revenue columns, they're not consistent, no one knows why. Who do I even ask about this? Then there are a whole class of problems where there might not even be a single correct answer. Do we want to count customers whose credit cards have declined as churned? For some metrics, that probably makes sense. For others, maybe not. And then everyone is familiar with the situation where the documentation don't match the data. The documentation says X event always follows Y event. But once we look at the data, we start to find examples where that's not the case. Is that a bug in my code? Is that a bug in the application code? Is the documentation wrong? Et cetera, et cetera, et cetera. Only once we finish those first two steps, which often end up being the bulk of the time of the data science project, can actually start doing any real data science at all. Our advanced statistical modeling or machine learning project, this is the part where the data scientists were actually trained for, where they're tuning models and experimenting with different feature sets, but it takes them a really long time to get there. Finally, at the very end, we get to another really hard problem, which is what do we actually do with these predictions once we have a model that we're happy with? I've talked with a number of data scientists who get to this point and they don't really know what to do at all. They end up feeling very frustrated that their work isn't having an impact on the business because they can't get their predictions, their model that runs on their local Jupyter notebook, into somewhere that's actually useful. I've been the data scientist with a model that's running via nightly cron job on my laptop with a do not turn off sticky note sitting in it in the office. It's not an ideal situation, but since most data scientists aren't trained as software engineers, the crucial part of the process can be a real blocker for them. So let's talk about what the data scientist wish list looked like. If I'm a data scientist coming into a new organization, I don't want to spend a lot of time writing the same cleaning and munging code over and over and over again. So I want to write all of my transformations at most one time. I want to have an easy way to reuse those transformations. I want to have access to a library of potential training features that I can easily summon to use in my model. So these are things that I can use in my model for doing some sort of prediction. Ideally, the library would rely on what other people in the organization have done so that I don't have to start from zero, so that I don't have to rebuild the wheel every time. But also it's a library so that if I come up with a new feature with something that's useful, I can save that in the library so that way other people can use it as well. And then finally, I want dead simple productionalization. As a data scientist, I want to have impact on our customers, impact on our business. I want to see my predictions out in the world, making a difference in our product and in our customers' lives. So I want to be able to get my models into production in the most frictionless way possible. I don't want to be blocked by a software engineering team that has their own other priorities of work to do. So I'd like for this deployment process to be as self-serve as possible. The easier it is for me to get my predictions into a place where they can be used and have an impact, the happier that I'm going to be as a data scientist. So these are the three things that a data scientist want out of their infrastructure so that they can be most effective. So what does this actually look like? Here's what my ideal data scientist model training workbook might look like. In this example, I'm imagining that we're working on some sort of lead scoring model where the objective is to look at our historic database of leads, model the likelihood of conversion based on what we know about those leads, and then use that model to rank new leads so that our sales team can focus most of their effort on the highest likelihood leads. This is a pretty standard ML application for a lot of businesses. There's basically three sections of this notebook. At the top, we have a query where we are getting data for the model. We're querying from a pre-existing table called leads. And this leads table has a lot of interesting information that's potentially useful to us. We have geography, calendar variables, traffic source, all of the data that might be useful, at least plausibly, in a lead scoring model. Critically, all of this information is also useful for basic reporting. If we have a dashboard for our business in our BI tool that's reporting out information on leads, it means that we've probably already collected, cleaned, and assembled all of this data. Here we want our data scientists to be able to easily make use of those pre-existing data to work on this prediction task. Here in the middle, we're just training our model. This can be as easy as a few lines to use a scikit-learn built in, or it could be as complicated as handwriting a deep learning model. The key thing to note is that this is where we actually want our data scientists spending most of their time, right? This is the key data science value add. At the very end, we've got some sort of imaginary function that will deploy this now trained model into production. This way, data scientists aren't looking at the AWS documentation, but rather they have access to a straightforward way to deploy their model into a place where those predictions can be used. So that brings us to the idea of the modern data science stack. In addition to using our warehouse to drive our BI applications and our ad hoc analyses, we can actually use our warehouse to power our data science efforts. For some of the audience, this might sound obvious. For others, this might sound sacrilegious. What I've noticed is that people who have only been working in data for the last few years tend to see this idea as obvious. But technologists who cut their teeth in the world before the modern data stack can find this a little bit disconcerting. The reason for that is that traditionally data warehouses were exclusively used for BI, and they tend to be optimized for doing pre-aggregations that facilitated reporting back when warehouses were disk or RAM constrained. So the warehouse was where the data cubes were built and managed, and they were used exclusively for reporting. Under the old paradigm, no one would dream of using the warehouse for anything production related, nor would data scientists want to use those pre-aggregated data that was stored in the warehouse. With the modern data stack and modern cloud data warehouses, this has changed. The cloud data warehouse supports working with large amounts of unaggregated data, and with the maturing of the ecosystem, we've brought more reliability and engineering rigor to the data pipelines we're building than was possible even 10 years ago. Unfortunately, partially because of this history, there are many data scientists who have a natural distrust of data warehouses and who are not working much with a data warehouse that's being managed by some other team somewhere else in the organization. The case that I want to make today is that this infrastructure is a really easy way to move from doing basic BI and analytics to doing data scientists while also making our data scientists actually effective from day one. So with the modern data stack, we get these first two items from our wish list easily and essentially for free. We can go write our transformation code exactly once, have that managed by dbt. If a data scientist needs to go create a new feature, they can write the SQL for it, deploy it via dbt, and then see the data show up in the table they're working with. We've got a library of potential training features via this centralized system. Not only can a data scientist rely on the work that other people are doing, including non-data scientists like analysts or data engineers, but also what other data scientists are doing. If there are multiple data scientists working, they can all contribute to this centralized repository of features, which means that no one has to go reinvent the wheel when they're working on a new project. The tougher piece here is the dead simple productionalization. How can we use this system to make it easy for our data scientists to get their predictions into somewhere that's useful? One exciting development in these modern data stacks is that people are developing tools to help extract data from the warehouse and send it to other applications. This could be back to production databases, to a CRM, a customer data platform, really wherever. Why would you do this? This is another area where some people are a little bit shocked when they see it happening. A lot of folks from the old guard, to them, putting the data warehouse in the path of production was a definite bad practice. But now that's changing. The reason why is that we as analysts and data engineers have done a great job of adding a lot of value through how we've built these pipelines to clean and make sense of our data. And some of the business wants to be able to make use of those data in the other applications. You can imagine something like a column indicating whether or not a customer is churned as being very useful for email campaigns that we want to manage. So there's a great example of the type of data that we might send from our warehouse to the email service provider or customer data platform. There's a number of different vendors who are working on this problem. A lot of interesting work being done. Definitely check them out. I think Census is one of them, but a number of people are doing this in a variety of different ways. Once we combine that with our modern data science stack, where we're using our data warehouse as the basis for our data science and machine learning efforts, we can start to think about our data warehouse not just as the source of our data, but actually as the central repository and hub for all of our data products. Obviously, we're going to suck the data out of our warehouse for our machine learning models, but what we can also do is have our models send data back into the warehouse. Then once those data are in the warehouse, we can use the rest of the infrastructure to forward those data along to where they need to go. So in a deployed model, we'll query data from the warehouse, use the model to make predictions, and then send the predictions back into the warehouse so that they can be passed along to our other applications. So if we think back to our lead scoring example, we can have our model make predictions for any new leads that have been loaded into the warehouse since the last time the model was run, write those predictions into the warehouse, and then we can forward those predictions into Salesforce or wherever our CRM is, along with whatever other data we're sending as well. This gets us a lot of nice features really easily. Reusing pipes means less data engineering work and more common knowledge with respect to how to work with the infrastructure. One nice feature is that we also get model observability metrics cheaply. If we're sending our predictions into the data warehouse, we can actually report out on the performance of our models, prediction accuracy, recall, whatever, via our BI tools. Since all of the data is stored in the warehouse, we can make use of this BI infrastructure to do model reporting and analysis. So instead of trying to use a separate system or tool for logging and monitoring these predictions, we can just build our dashboards right into the BI tool that the organization is already familiar with. One underappreciated benefit of this system is that if we build our data products on top of the central data hub in the warehouse, our data products can take advantage of the data quality flywheel. The data quality flywheel is the phenomenon of data quality improvements compounding in a centralized data source as many different people make improvements to data quality over time as they fix bugs and address issues that are surfaced in reports and in other analyses. The more people who are looking at the data, the faster the data quality issues can be identified and addressed. So if we build our model on top of, for example, a geography column, US state, and someone notices that there are two distinct Texas entries because of a capitalization issue, when that issue gets fixed, our model will also benefit. Our data science will also benefit. Our data scientists might not even be aware that there was ever an issue and that it was fixed, but it actually ends up benefiting the model. This data quality flywheel can actually work to counteract the natural entropy of data quality without the data scientists doing any additional work. Oh, we had bullets here I didn't click through. So we've got all of our boxes checked on the data scientist wish list. Once we have the modern data science stack set up, we can put our data scientists to work in an environment that's going to make it easy for them to focus on the things that they do best. Instead of waiting 6 months or a year for a data scientist to get up to speed and to figure out the data model, how to integrate their models with the relevant applications, we can go from idea to deployed model in a week. Okay, I'm about out of time, so I'm going to sort of rip through this next slide to get to questions. There are some ways that this doesn't work very well. There's additional overhead to using a tool like dbt. This can be frustrating for data scientists. Data scientists have varying levels of comfort working with tools like Git and GitHub, so that can be a blocker to getting them integrated into working with the system. And finally, some data scientists aren't comfortable in SQL. the modern data stack is a really SQL-oriented system, and a lot of data scientists are really comfortable in Python and R, but they aren't as comfortable with the big, complicated SQL transformations that a lot of people who are used to working with a tool like dbt are very comfortable with. So where do we go from here? The system that I've described is a great place to start, but it definitely doesn't cover all of the potential data science products we might want to build. Obviously, real-time predictions don't work very well in this paradigm. Anything that has to do with online learning, right, where you're trying to rapidly update and train the model, aren't going to work very well in this paradigm. And then finally, I didn't talk at all about testing and comparing models. This paradigm that I talked about actually generalizes nicely to that, but it is a thing. It takes more work and more investment on the data engineering side in order to actually go and build. So quickly summing up, I believe that now is the time for data scientists. Some people are already working in this paradigm, but for those of you that aren't, I want to encourage you to think about how you can help your data scientists be more efficient by building on top of the modern data stack. How can you take the modern data stack you have today and increase the value that you're getting from your data by building a data science platform on top of it? It's an incredibly exciting time to be working on data, and I'm looking forward to hearing about what all of you have built. Thank you very much. Now we're at time for questions. I think we have a few minutes.
Perfect. Yeah, we have 3 minutes. We have a few questions, and whatever we don't answer, we can answer on a follow-up blog post that you and I can work on. What if you're one of those data scientists who were hired way too early?
I mean, you're in for a rough ride. Like, you better learn how to be a data engineer is sort of my best advice to those people, or go find a different job, right? There's no shame in admitting that a job that you take isn't a right fit. But I mean, you know, a lot of us here today, right, are data scientists who ended up becoming sort of data engineers or analytics engineers simply by necessity. So if you're in that position, you sort of have to decide, like, are you interested in doing the work that's most valuable, which is setting up a modern data stack, building a lot of this BI infrastructure, or do you actually want to be, you know, training models, in which case maybe this isn't the right job for you.
Mm-hmm. Do you believe there's a need for data lakes, or can we have everything in the data warehouse with the ease and advancement of the modern data stack?
I don't really think that there's a need for a differentiated data lake for most use cases, for most businesses that I work with. There definitely are some businesses that have, you know, really big data problems. And so, you know, working with those data in Snowflake or Redshift or BigQuery can actually sort of be a real problem. They need to think about, you know, having a separate storage layer. For most businesses, for most like startups, for most small-ish companies, they don't really need that. Snowflake sort of has a combined warehouse and data lake, and it's really not worth thinking about differentiating between the two. That really excites me. I think that, like, that's definitely the direction to go. It means less sort of thinking about less infrastructure to manage. So for most use cases, I really don't think that there's a big difference. And I think, you know, tools like BigQuery and Snowflake are going to swallow up the need for a separate data lake for the vast majority of use cases.
Well said. Well said. Last question. Which business group at a typical non-techie company is usually asking for the insight that AI, ML type analytics? Is it finance, marketing, sales, or manufacturing? Is one group asking more typical than the other?
It really depends a lot on the business. I mean, in like internet-based companies, so, you know, newer companies, right, a lot of times it's marketing. All e-commerce companies are sort of driven off of marketing. And so a lot of them are really interested in different ways that data and data science might be able to help their marketing efforts. You also see sort of digital product, right? People are thinking about, how do we make our product stickier? How can we make our product smarter, right? So that there's sort of the quote unquote magic in the product. You know, where we can use data to predict what people are going to do and therefore make the product better. It varies a lot depending on the business. I haven't worked with very many manufacturing businesses, although it seems like there's surely a lot of fruit there to be picked. I don't know how low hanging it actually is. So I think it varies a lot. Finance tends to not be that interested in AI. You know, if you're an accounting person, like, you don't really want any magic in your spreadsheets at all. But sort of all of the rest of the departments, I think, tend to be really interested in how they can use AI and data in general just to work more effectively.
Awesome. Thank you so much, Michael. It's been a lot of information. Thank you.
Thank you.
Yeah. So we have our next session coming up with two individuals from Drizzly. It's going to be fantastic. So be sure to close out of this session and then join the next section in under the agenda tab in Pathable. But before we go, here's a message from one of our sponsors.
Struggling to understand your data? We take data from multiple sources, bring them into one place, and create dashboards that help businesses run more effectively. Our target market is small and mid-sized companies who either don't have the resources, expertise, or money to invest in an internal analytics team. We provide a state-of-the-art analytics platform and a dedicated analyst to help with your data analysis. Get back to running your business, schedule a demo, and learn more.